Hello. And welcome to Lesson 3 of Computer Graphics session of Spring 2017. Lesson 3 will build upon previous 2 and show how to send color data to Vertex Shader, along with some other useful concepts. Again, we need a browser, a programming editor like Sublime, the triangles.html file from Lesson 2, the webGl reference guide, and a little patience and determination. We start by first moving our JavaScript code to a separate file. Select all JavaScript code between the script opening and closing tag. Cut and paste in a new file. Save the new file as triangles.js. In the HTML file, add the source value to script tag. And since the .js file is in same folder as HTML, source is the file name. Triangles.html will keep working fine. The whole shader compiling and linking code is clustering our init function and JS file. Let's first move it to a new function, then to a new file. Select the code for making shader program. We call this new function init shader. Paste the code inside the function. We have to use the function keyword to make this a complete function. Let's make use of function arguments for easy use of the function. The arguments are the ID of the vertex and fragment shader script written in the HTML file. We also need the webGl context inside the function. Finally, let's return the complete linked program. Using the function is trivial and easy now, and cleans up the init function. Give the IDs of the vertex shader script and fragment shader script as arguments to the function. The triangles.html is still working fine. To move the function init shader in new file, select the whole function and cut by pressing Ctrl and C. In a new file, copy the function. We are saving the file in a common folder for other subsequent programs to use it. The triangles.html should not be running. Oops. Forgot to save. That is better. Reason is the init shader function is undefined since we moved it to utils.js and did not update the HTML file accordingly. Let us add another JavaScript source. The double dots and / tells to go up one level from the current directory or the directory of HTML file. This is called relative path as opposed to absolute path. A relief to see triangles.html working again. Time to do some real stuff and send data from vertex shader to fragment shader. The variable will be going out from vertex shader, hence, the qualifier out, vic4 is the data type and fcolor is the name. For now, just say that the position is the color for that fragment. The same variable must be defined in fragment shader but with qualifier in. Since the variable is arriving in the fragment shader, the frag CLR is now set to FCLR instead of always being blue. Wow! This is beautiful. Let's learn about interpolating versus vertex provoking. We just did interpolating. For every fragment rasterized, the value for FCLR was approximated or interpolated by using the 3 vertices of the triangle it belonged to. The smooth qualifier mentions this default behavior explicitly. However, using the flat qualifier changes the default behavior of interpolating to vertex provoking. In vertex provoking, on of the vertex dominates all other and its value is set for all fragments. Here it is the last vertex of the triangle defined. We move on to send more than one data to the vertex shader. Let's create another buffer. When working on this buffer, we need to bind it. Just change the buffer ID in the bind buffer function. To send data, we need buffer data function. But wait, we don't have color data yet. This is easily fixed. Okay. I admit, not that easily. Send this color data to color buffer. Need a input variable in vertex shader to point this color data to. We call it vertex color or VCLR for short. Now fragment color is set to color data of each vertex. Set the vertex attribute, that is, in variable, to the currently binded buffer. We need to change the data size since, now, 4 elements of our vertex color array is equal to 1, vic4 in variable in vertex shader. Oops. Forgot all those commas in the end. What a silly mistake. Relief to see everything working again. Let's see how it looks when interpolated. Amazing. It looks beautiful.